What do all the peaks in a vibration spectrum really mean? For engineers and students, deciphering these signals reveals the hidden workings of machines and structures. Let's unravel how multiple signals combine, creating complex spectral peaks, and understand the phenomena that shape them. Imagine several sine waves flowing together. Each is smooth and predictable, but when mixed, the results can be intricate. When multiple sine waves overlap, their interactions generate harmonics in some or different frequencies. The spectrum becomes more than the sum of its parts. This reflects real-world signals encountered in vibration analysis. Consider truncation. Truncating a waveform, limiting it to finite length, introduces sharp transitions that produce sidebands and spectral leakage. These artifacts add extra peaks unrelated to the original signal. Accurate interpretation demands awareness of these effects. Transients and impulses further complicate the picture. An impulse contains energy across a broad frequency range. Transients are longer but temporary, causing spreading in the spectrum and making peaks appear where there was only silence before. For vibration analysts, these phenomena often signal faults, impacts, or process changes. Amplitude modulation occurs when a signal's amplitude is varied by another. In vibration, this could represent a fault modulating the base vibration. Sidebands emerge around the central frequency. These are crucial for identifying mechanical issues like bearing defects or gear mesh irregularities. Beating arises when similar frequencies mix, creating periodic rises and falls, beats. In the spectrum, beating manifests as new frequencies, revealing subtle interactions often overlooked. Recognizing beats is vital for identifying closely related faults or coupled machinery. Let's see how these principles play out in practice. Imagine analyzing a spectrum from a rotating machine filled with peaks. By applying today's concepts, understanding sine waves, recognizing truncation artifacts, identifying transients, decoding amplitude modulation, and spotting beating, you turn confusion into clarity. Each peak tells a story, reflecting machine dynamics, faults, or process variations. Bold, clean graphics and motion visualize these phenomena. Waveforms unfold, peaks emerge, signals combine and transform, revealing dynamic interaction at the heart of vibration analysis. Through careful attention and technical skill, you build confidence in interpreting spectra, moving beyond uncertainty. With knowledge mastered, the power to diagnose, predict, and optimize machinery is yours. The spectrum becomes a roadmap. Each signal, each peak, is a clue. Combine theory with practical experience, and your skill set grows steadily. You bridge the gap between confusion and clarity, transforming complex signals into actionable insights. Next time you review a spectrum, approach it with newfound confidence, knowing that every phenomenon discussed shapes what you see, and ultimately, what you know.